The researcher is interested
Yes, yes.
in the effect of chocolate on depression, and beneficial effect will be present for people who without sense of humor. So one independent variable is chocolate and another independent variable is sense of humor, and the dependent variable is the depression. After this is clear to you, now the researcher takes 30 subjects to get dose of chocolate. Actually, he divided the dose of chocolate. He divided the groups on the basis of the dose of chocolates. 10 gets high dose of chocolates, 10 gets low dose, and 10 do not get chocolate. So here in this table, this is the table, none, those who had not taken any dose of chocolate. So this is the none, this is the group having low dose of chocolate, this is the group having high dose of chocolate. So this one, this is the dose of chocolate is usually called factor A, and second one is sense of humor, this is called factor B, and this factor A is called the main effect, and this factor B is called the main effect, sense of humor. Because when you solve this question manually, we use factor A or factor B, but in SPSS we assign the name of independent variable, and independent variable, this independent variable has these three categories, and this sense of humor has two categories. So researcher has divided the three groups, having chocolates or not having chocolates, or having low dose of chocolate, high dose of chocolate, or no dose of chocolate. After this, each of the student is also assigned another variable, independent variable, sense of humor, having sense of humor and not sense of humor. So in which one group having sense of humor, this one group, this is the column wise. Sense of humor is column wise, and dose of chocolate is row wise. The scores on the depression scale is dependent variable. Now the question will predict, number one, researcher will predict there is a significant interaction between dose of chocolate and sense of humor. You know, there is a one variable A, there is another variable B. So there must be the effect of A on B, and this is called the interaction effect, and in two-way ANOVA we measure the interaction effect. Are on the variable view. This is the variable view of SPSS that is open to you, and you can view it now. You can view the variable view of SPSS, and you know, in name I have written here dose of chocolate, and you know we will assign values dose of chocolate. In dose of chocolate we have three groups. So one, I have assigned the value 1 to none, and assigned the value 2 to low dose, and assigned the value 3 to high dose. Clear? And second variable is the sense of humor, and I also assigned the values in sense of I also assigned the values to sense of humor, and one is assigned no sense of humor, and 2 is assigned sense of humor. Okay, so now this is the depression, and depression is the scores that would be entered in on data view, and this is the data view. It is it visible? Have the three groups, 1 2 3, and second we have the, you know, one. In one, again I go to, here is how many ones here? Almost 10 subjects having dose of chocolate. We have assigned one value to, we have assigned one value. Again, I am inspecting the values. We have assigned one value, none. Please remember, we have assigned 1 value to none, 2 value to low dose, 3 to high dose. Okay. So here in data view, you see first 10 we assigned 1 value, they are not taking any dose of chocolate, and 2 assigned to low dose of chocolate, and 3 assigned to having high dose of chocolate. So in 10 subjects, 5 subjects having the sense of humor, 1 has the sense of humor. Again, I check, inspect, sense of 1 has no sense of humor. Okay. So on data view, 10 students having, they are not taking any dose of chocolate, in which 5 have no sense of humor. So I have assigned these 5, 1. These 5 subjects have no sense of humor, and these 5 subjects have sense of humor, and these are the 10 subjects taking no dose of chocolate, and these are the 10 subjects taking low dose of chocolate, and in which 5 subjects have no sense of humor, and 5 subjects have sense of humor. And again, I'm scrolling down, and in this number, value 3 indicates subject having high dose of chocolate, in which 5 subjects have the sense of humor, and other 5 subjects have no sense of humor. Is it clear? We have assigned the values. Now I have inserted, against these values, I have entered the depression scores, right? So I have the score on depression, and I have entered this score in this column of SPSS. Now I'm going to perform the two-way ANOVA. So for performing two-way ANOVA, first I go to the analyze, and first you go to analyze, then general linear model, then univariate. Clear? Analyze, general linear model, univariate, right? So you know what is the dependent variable here? Dependent variable is the depression score. So I select the depression score, and with the help of arrow, shift it to dependent variable. And now I select these two variables, dose of chocolate and sense of humor. These will go to the fixed factor. This I've done. And now first go to the plots. First I select the button plots, and in plots, dose of chocolate will be on a horizontal box. I will shift to the horizontal box, and sense of humor on the separate lines. Clear? Clear, student? Note it, please. Now I
Clear.
Now I add it and continue, and then I select the post hoc. Post hoc. In post hoc, we select this dose of chocolate from the factor to post hoc. We shift it to post hoc, and here you see there are number of tests, Weller, Deccan, and Dennett, and Tucky, and Tucky B. So we select usually Tucky, right? So I continue this, and this one is now I select the option, and in option we check descriptive, we check effect, estimate of effect size, we check homogeneity of test, and continue, and press the button OK, and we will get the output. Here is the output. Now I'm sharing the output with you. So now again I'm inspecting the dose of chocolate. So the value assigned 1, so is they did not take any chocolate. These are the 10 students, none. 10 students low dose, 10 subjects high dose, and 15 subjects sense of humor, and 15 subject no sense of humor. So here is the mean and standard deviation value inspecting the mean and standard deviation value, you can see here by inspecting the mean and standard deviation value, whether the sample sizes are roughly equal. I like to run a mean table for inspecting this. So this is, the means and sample size. Sample size are roughly equal in this example. Are you agree with me? Roughly equal because the subject having dose 5, subject no dose of chocolate 15, total 10, and in which 5 sense of humor, 5 no sense of humor, and subject low dose 10, because these are the equal sizes. When sometimes it happens sample sizes are roughly equal, this means that we do not need to bother about the homogeneity assumptions. We can therefore skip Levin's test. But here is the Levin test. We cannot skip. Here is the Levin test. And homogeneity of variances, the third assumption. What was the third assumption? The third assumption is the population from which the samples are selected must have equal variances. So you can see here the population, Levin's test is in front of you, and the population from which the samples are selected must have the equal variances, and this assumption is met. This test between subject effect is very important for us, because this is the F value. The F value is used for two-way ANOVA, and this is the mean square. This is the degree of freedom, because in degree of freedom this is the partial eta square value, because this value is important for us. Dose of chocolate is 22.482, and sense of humor, this is significantly different. You can understand. So mean of the dose of chocolate among 3 groups is significantly different, because the F value is 22.48, and this is significant because this P value, this significant SIG is indicated by P value, and this P value is less than 0.05. So when the value of P is less than 0.05, mean differences occur in the groups, right? So here is not mean difference significant, because sense of humor, the P value is not less than 0.05, rather it is greater than 0.05, because it is in fact it is 0.08. So it is greater than 0.05. So difference exists between sense of humor and no sense of humor. Mean is not significant, and interaction effect is significant, because the interaction effect is, what is the interaction effect? The dose of chocolate interact with sense of humor, and when these two factors interact with each other, there is a significant difference, because P value is less than 0.05. So this is the output, and this is the multiple comparison. And in multiple comparison, you see the subject having low dose and subject did not take any dose. No significant difference exists in between these two, and significant difference exists none and high dose, because this P value is less than 0.05. And again, in this second column, the second row, low dose and none, no significant difference. Low dose and high dose, significant difference. Low dose and high dose, significant difference, because P value is less than 0.05. High dose and none is significant difference, because there is significant difference between the subjects having high dose of chocolate and no dose of chocolate, right? Of course, there would be a significant difference in the depression of the subjects who did not use chocolate and the subject who used chocolate. So there is an effect of chocolate on the depression, and the subject who use high dose of chocolate, then the subjects use low dose of chocolate, because this high dose and this low dose has significant difference. P value is less than 0.05. This is all about the output. And now I go to share with the result. It also indicates no significant effect of dose of chocolate was observed on depression for subjects who have sense of humor. It tells you another thing. Did you notice this last line? It also indicates no significant effect of dose of chocolate was observed on depression for subjects who have sense of humor. Who have sense of humor, because in output factor dose of